Welcome to Insight Engine Academy. In this video, we will discuss different types of acids. In class 10th chemistry, acids, bases and salts. In a previous video, we discussed acids turn different indicators into different colors. Acids turn blue litmus to red color, methyl orange to red or pink color, phenolphthalein becomes colorless, right? We discussed. So the substances generally which turn blue litmus to red color, methyl orange to pink color, phenolphthalein to colorless are generally what? Acids. Among all the acids, we can classify them into different ways. First, based on source of acids. We have two types of acids. Number one, we say organic acids. What is the source of organic acids? Source of organic acids are plants, okay? It's like fruits and vegetables, and some animals are the source of organic acids. They are natural. They are not man-made, they produce in nature. Right? What are the examples of acids? Organic acids. We say citric acid, then let's say lactic acid, butyric acid, tartaric acid, acetic acid, malic acid, tannic acid, uric acid, oxalic acid, formic acid, etc. These are the examples of organic acids. Then how about their source? You think the sources are vegetables, fruits and other animals. Let us see the sources of first citric acid. We know citrus fruits like lemon, orange, that pulpy fruits are the sources of citric acid. Next, lactic acid. It is present in sour milk or curd, contains lactic acid. Cheese contain butyric acid. Tamarind contain tartaric acid. Acetic acid is present in vinegar. Malic acid is present in apple. Tannic acid is present in tea leaves. Uric acid is present in urine. Oxalic acid present in tomatoes. Tomato, spinach contains oxalic acid. Formic acid is produced by red ants, etc. Right? These are the few organic acids and their sources, right? So these acids obtained from only plant source, animal source, like you see formic acid is produced from red ants like this. Next, second category, if you can see, it is inorganic acids. Inorganic acids are also called mineral acids. The source of these acids is mineral. The acids that are obtained from minerals are called mineral acids, or these acids are also called man-made, artificial acids. So they are prepared from chemicals, in laboratory. Right. What are the examples of inorganic acids? It is very important to remember the chemical name, chemical formula of inorganic acids. Let's write first one, HCl. It's called hydrochloric acid. Next, H2SO4. It's called sulfuric acid. Next, HNO3 is nitric acid. H2CO3 carbonic acid. H3PO4 phosphoric acid. Etc. are the examples of mineral acids. They are obtained from mineral source. They are prepared artificially in the laboratory by using various chemicals. So they all are called inorganic acids. Okay. Now let us see why are those substances as considered acids. For example, let me take acetic acid. Acetic acid formula is CH3COOH. If I take another acid, let's say hydrochloric acid, is represented by HCl. This is a organic acid. This is a inorganic acid. But why only these substances are considered as acids? Because any acids, if you can see the structural formula of acetic acid, it will be like this: CH3, carbon valency 4, so carbon can form 4 bonds, COOH. This is a acetic acid. Now, when this acetic acid, this is hydrochloric acid, hydrogen is bonded with chlorine. Now, if I see CH3COOH, when added to water, it produces, it's split into CH3COO minus and H plus. Right? This H plus combines with water molecule and produce H3O plus ion. This is called hydronium ion. Now, if I take a HCl in water, it produces H plus and Cl minus, and this hydrogen ion combines with water molecule, produce hydronium ion. Now, what is common in both the substances? Whether you take CH3COOH or HCl, they are able to produce H plus ions or H3O plus ions in water, in their aqua solutions. Such substances which produce H plus ions or H3O plus ions in aqua solutions are generally called acids. So now if we see in all the examples, organic acids, whether inorganic acids, all acids when added to water in their aqua solutions, they produce H plus ions or H3O plus ions, hydronium ions, because all acids are soluble in water. When they dissolve in water, they produce H plus ion. So all acids commonly produce H plus ion. So any substance that can produce H plus ion when dissolved in water is considered as acids, whether irrespective of its source, whether it from natural sources or man-made. If they can produce H plus ions, they are called acids. Generally it can be organic or inorganic. This is a common thing in all the acids. If you see, for example, H2SO4 sulfuric acid, when added to water in its aqueous solution, produces 2 H plus ions and SO4 minus 2 sulfate ion. Is it clear? So this sulfuric acid also produces H plus ions in aqueous solution, so it is also termed as acid. Okay, now let us discuss more types of acids. First category is based on source, organic and inorganic, and let us see different other categories of acids. The second category of acids is based on their strength into two categories. First category is strong acids. We learned all acids produce hydrogen ions, right? But all acids cannot produce same concentration of H plus ions, right? For example, some acids dissolve more, like some acids dissociate completely and produce high concentration of H plus ions. Such acids are called strong acids. They undergoes complete ionization. So we'll write strong acids undergoes complete ionization. As a result, produce high concentration of H plus ions. For example, if I say HCl in water solution undergoes complete ionization and produce a high concentration of H plus ions. Number 2, I take a H2SO4 solution. This H2SO4 solution also produce H plus ions and SO4 minus 2 ions. We'll write other examples of strong acids. Number 3, nitric acid, HNO3 in water produces H plus ion and NO3 minus 1 ion, right? Hydrogen ion and nitrate ion. This is nitrate ion, this is sulfate ion. Generally, any negative radical, sulfate, nitrate, when combines with hydrogen ions, they produce, if you can imagine, reverse reaction. Sulfate or nitrate combines with hydrogens, produce their ic acids. Nitrate ion produce nitric acid, sulfate ion produce sulfuric acid, chloride ion produce hydrochloric acid. Okay, in reverse we can imagine, right? Now these are the strong acids. They undergoes complete ionization, produce high concentration of H plus ions. Number 2, second type in this category is weak acids. This is opposite to strong acids, right? They undergoes partial ionization, which means they do not completely ionize. As a result of this partial ionization, low concentration of H plus ions are produced. Low concentration of H plus ions are produced, which are called weak acids. If you see example, all organic acids are weak. Along with some other mineral acids are there which are also weak, like carbonic acid, phosphoric acid, etc. They are also mineral acids, but even they are weak acids. They undergoes partial ionization and produce low concentration of H plus ions. Now let us understand what is this ionization. Like if I say, if I take H2CO3, it produces hydrogen ions and along with the carbonate ion, CO3 minus 2 ion, right? It is an example. But what happens generally when these acids are added to water. Now let us understand, okay, with this example. Let me take distilled water in a beaker. This is, let's say, distilled water. To this distilled water, if I add 1 mole hydrochloric acid. We know 1 mole hydrochloric acid contain Avogadro number of HCl molecules. In 1 mole, when it is added, almost 90%, above 90% of HCl molecules ionizes above 90 to 99% of HCl molecules undergoes ionization. As a result, if I take HCl like this in water, it split into H plus and Cl minus. Almost all molecules, if I take 100% split to produce 100% of HCl molecule. So in solution, this is what is it? It is now becomes acid solution. Which acid, Nana? Hydrochloric acid solution. In HCl solution, like being it is a strong acid, in strong acid solutions, all ions only present, all ions are present, but molecules, no molecules are present because they undergoes almost no molecules present. They undergoes almost complete ionization. All the molecules are turned into their ions, H plus ions and Cl minus ions. This is one example. Likewise, if you see any other strong acid, all strong acids when added to water, they undergoes complete ionization. As a result, we cannot see any molecules present in it. Whereas if you take another solution of a weak acid, right? This is, let's say, let's prepare solution of a weak acid. This is, let's say, distilled water. To this distilled water, I'm adding carbonic acid, CH2CO3. It's a formula of carbonic acid. How to get carbonic acid formula? Carbonic acid is produced from carbonate ion. Carbonate ion added to hydrogen ions becomes carbonic acid, H2CO3. So we know, right? This is like H plus 1, CO3 minus 2, crisscross, plus minus cancel, crisscross the valencies, 2 comes here, 1 into CO3, H2CO3 is a formula of carbonic acid. Now this carbonic acid when added to distilled water, it undergoes ionization. But if I take 1 mole H2CO3, out of 1 mole, let's say, is split into 2H plus CO3 minus 2. Only if I take 1 mole, out of 1 mole, let's imagine only 0.3 mole, example, 0.3 mole only convert into ions, whereas remaining 0.7 mole will be in the form of undissociation form. H2CO3 molecules are there. Now this is a solution of a weak acid that contains ions as well as molecules. But if you see a solution of a strong acid, almost all ions are present, no molecules are seen in such strong acid solutions. From this we understand what are strong acids, what are weak acids. Is it clear? Strong acids undergoes complete ionization, produce high concentration of H plus ions, whereas weak acids undergoes partial ionization and produce low concentration of H plus ions. So in these weak acid solutions, we also see molecules along with the ions. Now let us discuss third category of acids based on the basicity. Let us see what is meant by basicity of acid. If I take any acid, it contains hydrogen atoms. Now number of replaceable hydrogen atoms in one molecule of acid right, is called a basicity of acid, which is also equals to number of OH groups, number of OH bonds, we can say, in one molecule of acid. Is called its basicity of the acid. Based on this basicity, acids are generally divided into three types. One is a monobasic acids, the name itself gives us mono, single, basic, represent basicity of acid. So the acids whose basicity is 1 are called monobasic acids. For example, if I take HCl, one molecule of HCl when added to water produces one H plus ion and a Cl minus ion. Since it can produce one H plus ion, and it is called monobasic acid. Let us take another example, HNO3. When added to water, it produces H plus ion and a NO3 minus ion. So one hydrogen atom, right? Now if you just check this, right? In nitric acid, let's go with another example, CH3COOH, right? In water. Now you can see number of replaceable hydrogen atoms in one molecule is called its basicity. Now in acetic acid molecule, 3 plus 1, 4 hydrogen atoms are present. Out of these 4 hydrogen atoms, how many atoms are replaceable? What is its basicity? I am writing, though it contains 4 hydrogen atoms, it is comes under monobasic acid because it said like one replaceable hydrogen. So it produces CH3COO minus plus H plus. Sir, how do we understand that this produce only one hydrogen? Now if we know its structural formula, then identifying the number of OH bonds present in one molecule, we can identify its basicity. For example, if I take this CH3COOH, I write like this, CH3COOH. The hydrogen atoms which are bonded to carbon directly are not replaceable. They are not replaceable hydrogens, but the hydrogen that is bonded to oxygen is replaceable. So you can see OH. Since it has one OH bond, one replaceable hydrogen, and its basicity is considered 1. Okay, these are the examples of monobasic acids. Let us take second category is dibasic acids. Dibasic acids, the name itself gives us di represents 2, basic, basicity, acids. The acids whose basicity is 2 are dibasic acids. Basicity is 2. Now let us look at the examples of dibasic acids. I will write H2S. If I write H2S is an example, the liquid of H2S is an example of acid H2S. It produces 2H plus S minus 2. Since 2 hydrogen ions it can produce from one molecule, and it is called a dibasic acid. Now let us discuss, let us have one more example, H2SO4 in water. Everything ionized in presence of water only. H2SO4 ionized in the presence of water produce 2H plus and SO4 minus 2 sulfate ion. Now if you look at the structural formula of H2SO4, I will write here structural formula. S will be at the center, 2 double bonded oxygens, 2 OH groups, 2 OH bonds. Now you can see this sulfur in this one molecule of sulfuric acid, we can find 2 OH groups, and these 2 hydrogens are replaceable, and hence it is a dibasic acid H2SO4. So we can also go with some other examples. H2CO3 in water produces 2 H plus ions plus CO3 minus 2. etc. are the examples of dibasic acids. H2S, H2SO4, H2CO3, oxalic acid. Let's go with the oxalic acid. Oxalic acid is organic acid or inorganic acid? What is its source? Recall its source. Its source is tomato or spinach, since it is come from fruits and vegetables. So it is a organic acid and its formula is H2C2O4. What is it? H2C2O4. In its solution of water, it produces the 2H plus ions and it also produces this oxalate ion. These are few examples of dibasic acid: hydrogen sulfide, sulfuric acid, carbonic acid, and oxalic acid. Right? Now let us discuss the third type. Now the third type in this category is tribasic acids. You can understand now the basicity is 3. Let us see examples of tribasic acids like H3PO4. H3PO4, when added to water, one molecule able to produce 3 H plus ions and a phosphate ion PO4 minus 3. Phosphate ion combines with hydrogens, produce phosphoric acid, right? And when it is added to water, it also ionizes, produce hydrogen ions and phosphate ions. Now if you look at the structure, sir, how can you say all the 3 H plus ions are replaceable? I already told you. What is it? Number of replaceable hydrogen atoms is equals to number of OH bonds in one molecule. Now let us see the structure. To understand number of replaceable hydrogens, we need to find out number of OH bonds. So let us see H3PO4 structure. So I am writing phosphorus at the center. One is double bonded oxygen and remaining 3 OHs are bonded with phosphorus. Okay, hydrogen bonded with phosphorus by means of oxygen. So now you can find a number of OH bonds. This is one OH bond, second OH bond, third OH bond. Since 3 OH bonds are there, so it's these 3 are replaceable hydrogens, making the basicity of the acid is 3. Whereas let's say another example is phosphorus acid. Phosphorus acid, here its formula is H3PO3. Okay, now how to find out its basicity? It is an example of dibasic acid. Dibasic acid, but it seems, how many hydrogen atoms? 3 hydrogen atoms it contain one molecule, but all the 3 are not replaceable. How do we understand? If you look at its structure, I'll write phosphoric acid, phosphorus acid, H double bond O, then 3 hydrogens. We have 3 out of 3 oxygens, one is double bonded, remaining 2 oxygens bonded to hydrogen, right? This is, let's say, bonded to hydrogen, and 1 hydrogen is directly bonded to phosphorus. So now you can see 1, 2, 3. 3 hydrogen atoms are there, but the 3 hydrogens are not bonded to oxygen. Among these, one is directly bonded to phosphorus, which is not replaceable. These 2 are only replaceable, hence its basicity is only 2. Right? So it is a dibasic acid. Like this, if you can write the formula of any acid, then we can write, we can identify its what is it? It's a basicity, and based on basicity we can categorize them into monobasic acids, dibasic acids, or tribasic acids. It is one of the types of classifications, right? First one is based on the source of acids, based on strength of the acid, based on basicity of the acids, right? Now let us look at, there is another category of acids. It's based on nature of the elements present in it. Yeah, now another category of acids based on the elements present in it is into two types. One is binary acids, second one is ternary acids. Let us see first binary acids. Its name give us binary means two components generally. So here in this context we understand acids that have two elements, since it is based on elements. The acids that contain two elements are called binary acids. These binary acids are also called hydracids, right? Now they contain, these hydracids or binary acids contain a non-metal, a hydrogen atom, and other non-metal. And other non-metal, they are called binary acids. Now let us see example, hydrochloric acid, HCl. We have hydrogen and chlorine is a non-metal. This is one binary acids because two elements, hydrogen and chlorine, two elements. Let's say H2S, hydrogen sulfide, we have hydrogen and sulfur. So binary acids, let's say HBr, hydrogen bromide, hydrogen and bromine, HF, hydrogen and fluorine, etc. are the examples of binary acids. They contain only two elements. One is hydrogen, second one is any other non-metal. Okay, now the second type in this category is ternary acids. Ternary acids are also called oxyacids. This classification, it is more important to understand this lesson into binary acids and ternary acids. Binary acids called hydracids, ternary acids called oxyacids. Now, as it name, you see ternary means three components. Here each component is element. We understand there are three elements in this acid, then they are called ternary acids, and in other name oxyacid convey that oxygen is also present. Now we say it contain hydrogen, three elements, right? It contain hydrogen, oxygen and other non-metal. They are called ternary acids or oxyacids. Let us write examples. If I write H2SO4, sulfuric acid, hydrogen is present, sulfur is present, oxygen is present. I write HNO3, hydrogen, nitrogen and oxygen. I write acetic acid, CH3COOH, carbon, hydrogen, oxygen, three elements. Likewise, you can write H2CO3, H3PO4. Okay, now H2C2O4, etc. are the examples of oxyacids. They contain hydrogen, oxygen and any other non-metal. This is another category of based on the elements present in it. Now another category based on concentration of acids. Based on this, acids are divided into two types. One is dilute acids, second one is concentrated acids. Firstly, what is meant by concentration? Concentration of acid solution, which means simply amount of acid. Generally acids are identified by H plus ions. Amount of acid in unit volume of the solution. Let us understand, it's called concentration. Let us understand this concentration with this example. Now I take for example 1 liter acid solution. 1 liter acid solution. This 1 liter I consider unit volume. In this unit volume, if I add, if it an acid solution, it contains H plus ions, right? Now in 1 liter acid solution, how many H plus ions present? Number of H plus ions is called its concentration. Concentration. This concentration is expressed in mole per liter. This can be also written like this, mole liter inverse. If I, for example, if I say 2 mole per liter, 2 mole per liter is a solution 1, acid solution 1, let's say. Another one contain 5 mole H plus ions per liter. This is a solution 2, acid solution 2, right? Now among these two solutions, we can say this is 2 mole per liter, this is 5 mole per liter, this is a high concentrated, this is low concentrated acid. I hope you understand. Concentration means amount of H plus ions present in unit volume of the solution. And here we always express the number of H plus ions are relatively very large, so that we use a suitable, a convenient unit to express the amount of hydrogen ions is mole. So mole per liter, mole, how many moles of hydrogen ions per unit volume of the acid solution is generally called its concentration. Now based on the concentration, acid solutions are two types. One is a dilute acids. Throughout this lesson, we use this word dilute acids, dilute acids. What is actually dilute acids? Dilute acids are the solutions which have, okay, less number of H plus ions per unit volume of the unit volume of acid solution, are called dilute acids, right? Then second one is opposite to this is concentrated acid, concentrated acids. These concentrated acids have more number of H plus ions per unit volume of its solution, unit volume of solution. So they are called generally concentrated acids. We hear acids are very dangerous. We listen outside, right? So we should deal with acids very, very carefully. If they generally fall on skin, they causes very severe burn injuries, right? So these acids, but what type of acids are very dangerous? Concentrated acids are very dangerous, because concentrated acids produce more H plus ions, and that more H plus ions produce more heat energy, right? And here, for example, let's take concentrated acid. If I take a concentrated hydrochloric acid, this concentrated, if I take 1 mole per liter, concentrated hydrochloric acid produce 1 mole H plus ions and 1 mole Cl minus ions per unit volume. Like for dissociation of each and every molecule, some amount of heat energy is released. So dissociation of acids is called exothermic reaction, which produce heat energy. If the taken acid is very concentrated, like it contain more number of H plus ion, more number of HCl molecules, and that produce high concentration of H plus ions, and also along with it produces excess heat energy. Because of that heat energy produced, it causes severe burn injuries. That is why concentrated acids, dealing with concentrated acid is very dangerous. Whereas you can use dilute acids. Even you take a strong acid, HCl, but it is in diluted form, you can take, and we do all experiments in laboratory using a dilute acids. Why dilute acids? Because dilute acids are not that much dangerous as concentrated acids. So they cause very, very less burn injuries. They do not harmful. So we can use dilute acids in the laboratory. And here one thing, generally people confuse it, these two terms. One is strong acids and second one is concentrated acids. Mostly you consider these two are synonymous, and somebody consider weak acids and dilute acids are same. Okay, but actually these two, strong and concentrated, are not equal. weak and dilute are also not equal. They have different terms, they have different meanings. If I say strong and weak based on the rate of dissociation, the degree of dissociation, strong acids like HCl, H2SO4, HNO3, they generally dissociate. Whatever the quantity of water available, they undergoes almost complete dissociation and produce high concentration of H plus ions. So they are called strong acids. Okay. Whereas concentrated acids means this acid solution can be strong acid solution or weak acid solution. If it contain more acid per unit volume, it is called concentrated, right? Coming to weak acid and dilute, weak acids are always weak, okay, whether in concentrated solutions or dilute solutions. Weak acids remains weak. For example, lemon contain citric acid. Whether you take more acid in less water, concentrated lemon solution, or dilute lemon water, it doesn't harm us because it's by nature it is weak acid. By nature it is weak acid. So weak acids, even in their concentrated solutions or dilute solutions, they are not harmful. But coming to strong acids, in dilute form, they are not harmful. But when they are in concentrated form, in their concentrated solutions, are very much dangerous. And while dealing with strong concentrated acid solutions, we have to be very, very careful. This is another type of another category of acids based on the concentration. They are into dilute acids and concentrated acids. I hope you understand this.